Hello, everyone. I'd like to start off by saying thanks for attending our webinar today on paths to migrating your data. Before we begin, I'd like to briefly review some logistics with you. Today's webinar will be approximately 30 minutes long, after which we'll have 10 to 15 minutes of Q&A. So I'd like to encourage you to ask questions in the chat window during the presentation. This event is being recorded and will be made available for on-demand viewing. And my name is Kyle Hunter. I'm responsible for ObjectRocket's product marketing, and I'll be your host for today's event. I'm joined today by Andy Woodard, one of ObjectRocket's data migration specialists, who will be covering common causes for migrations, how to plan for a successful transition, some common gotchas, and help you think about pros and cons of the most common paths. We'll follow that up with some time for Q&A. So with that, Andy, I'm going to let you take over and begin your presentation as soon as you're ready to go.
All right, thanks, Kyle. As Kyle mentioned, I've been running migrations at ObjectRocket for about 2 years now, and just kind of wanted to share some of the thoughts that we've had around setting up migrations for databases and what we can do to help with you guys planning your migrations. One of the main things that people are looking at when they're migrating their data is they're looking for new technologies, they're looking to increase the performance of their databases, reliability, or a lot of times it's looking at costs. Everybody is cost conscious, so different providers provide different costs for different services as well as different platforms. So with that, what we would like to know is what are some of the reasons why you have or will need to migrate your data? If you guys could go ahead and answer the question there. Okay. And see, it looks like majority of the folks were looking to adopt a new technology, which isn't very surprising. It's what we hear a lot, especially since we do a lot of NoSQL technologies. This is kind of outside the realm of the standard relational databases that people have been running for decades. So what we've done is we've worked with a lot of different customers to migrate a lot of data, especially with platforms like MongoDB and Redis. And during that, there's a lot of areas that you need to focus on that I don't think people really understand until they start going through this process. And one of those main things is planning. Having a well-developed plan and getting everything together that you need to for your migration is going to help with making sure that you reduce the risk of data loss and reducing the amount of downtime that you have, as well as making sure that you understand all the areas where you need to switch over in your application. And if in the event that something happens, you're ready to roll back and you can move back to the platform that you were on without a very large impact to your customer. So with that, a lot of the stuff that happens during this process of setting up the migrations is we have conversations with clients on a very regular basis. And what we do is the first thing we do is we capture requirements around what it is that they're looking for. If they're looking for a new database technology, if they're looking for the new platform, then we kind of try and help them fit their data in the right place. Some of these migrations start off with we're using MySQL and we would like to move into Mongo, or we're using, this is what we would like to do, and we would like to use MongoDB because we're trying to do full text search and do analytics on our data. So then we can sit down and talk about that a little bit and say, well, MongoDB might not be the best solution. A better solution would be something like Elasticsearch for doing that. So then what we do is we go through and we estimate the amount of data that's there, how the application accesses the database, and how much downtime is acceptable, and then we start developing the plan. And this plan can be something that's pretty simple and a couple of steps, or something that can be really complex, especially for moving technologies. So with that, I know I've said planning probably half a dozen times or so far, and that's for a reason. It's extremely important. And during this process, what we want to do is we want to make sure that we have all of the information that we need, including all of the servers, all of the data points, all of the access patterns for the application. So that way we can kind of map out everything. We can set up the environments on both sides and get everything ready so we can start replication, or we can start testing backup and restore the data. And we can make sure that everything looks okay on the new platform, because as everybody knows, you don't always looking at the same hardware from source and destination or the same provider. So you want to make sure that all of your access works well. And with that, making sure that you understand what a rollback looks like. What does your recovery look like? If you get through this thing and you start to see issues or performance isn't what you expect it to be during the migration, then having that plan in place really helps us kind of fall back on the source side, so that way we can reevaluate what is going on and any modifications or maybe optimizations we need to make on the destination side before we get going. So with that, there's really two main considerations, and that's making sure your app stays running. And this is reducing the amount of downtime that you have. One of the ways that we can do this is we love to use a method where we use replication and we kind of extend the cluster into another environment. A really good example of this is I worked with a client who was really interested in just kind of getting the migration going, and they were looking at doing a dump and restore of their data because they felt that was the easiest and cleanest way. And while it is fairly easy to do that, they also had some huge downtime concerns, and they were using a lot of data. So one of the problems with that is that when you do a dump and restore, in order to kind of prevent yourself from having any issues with data integrity, you really need to look into another solution, because you need to stop your application in order to keep the integrity of your data. So we worked on a solution where we set up replication. In this case, it was Mongo, from one Mongo replica set into additional nodes that are on the destination side. And with that, we were able to replicate all the data over and create a plan for switchover that would only take about 2 to 5 minutes of downtime in order to make that switchover, which means that the applications can stay running with a very small hiccup in between and have very little impact to that client's customers. The other side of it is reducing the risk of the data loss. As I mentioned, with data integrity, it's a very huge thing. And this isn't to say that doing cluster replication is going to cause any data loss. It's just that with doing a method like the dump and restore that I just mentioned before, you can make sure that your data is the same as it on the source as it is on the destination, because you're stopping your application. You're doing a dump of that data as it was when you stopped the application and restoring it to the other side. And when you restore it, a lot of what we do is we verify counts and we make sure that the data looks like it does on the other side. And this is something that we commonly see with MySQL, because MySQL replication is very difficult to set up for a lot of people. You have to take a backup and restore of the data. Then from there, you have to take binary logs and start applying them to the slave, and you have to make sure that the slave stays in sync. And with network latency these days, it's really hard to do that without incurring replication lag. So it's a lot easier to just temporarily take a maintenance in your application, stop the traffic, and do a backup and restore of it. And it's the safest way to make sure that you're not losing any transactions during that process. So with that, the three main paths are the backup and restore. The major downside of this one is the longer downtime that it's going to have. And this is because you need to stop the application writes and changes to make sure that you're not going to lose anything during the process. then the restore usually for this takes quite a bit of time, especially if you have a large data set. So with this, we've seen cases where backup and restores have taken a couple of hours just because of the size of the data. But the clients that I've worked with, they are able to take a maintenance. They can put the application in maintenance mode, and they can warn their customers ahead of time saying, hey, we're going to be doing database migrations. And we're going to do that on this date at this time, and it's going to take approximately this long. So that allows them the opportunity to do the dump and restore method. So they have a little bit of time to take and test and verify that all the data is exactly the way that they need it to be on the other side. But it's a very manual process because you need somebody to monitor the backup and make sure that it's continually running. And the same thing with the restore on the other side. For the cluster extensions and replication, it's a lot more complex to set up. There's a lot of moving parts. You need to move into networking pieces here. You need to make sure that you have networking end-to-end opened up, but not open up too much to where you're looking at opening yourself up for risk from the outside. You also need to make sure that you have all of the security pieces in place within those databases. For example, MongoDB uses a key file to have different nodes authenticate to each other. So it's making sure that you have the key file matched on either side. But once you set it, you can pretty much let the internals of the database do the work for you. So you don't have to continue to monitor it. The only thing that you sometimes have to make sure of is watching out for replication lag, which if you're moving from one database platform to another, one region to another, as long as those regions are relatively close to each other, it's not going to be a huge issue. Next slide is custom code. This can be anything from setting up your application to do dual writes from your current location into the new location. And this could be something where you take a snapshot of your data and move it to the new location, and then have application logic that settles deltas for you. Make sure that the data that you have looks a little different on your destination side, and it kind of settles those and gradually moves over to the new location. Another side of this is doing something where you have code that just periodically takes chunks of data from the old location, moves it into the new location. This can have different levels of downtime depending on the method that you take, and the complexity can change. If you're trying for an extremely low downtime scenario and you want to do it really fast, then it's something that could turn into something that's very complex like we see with the cluster extensions, but this is something that we can't rely on the internals of the database to do. The visibility inside what is going on is a lot harder too, because you can increase your complexity if you want to increase your visibility, because you can use monitoring platforms to instrument the migration code that you have so you can see what's going on, but that can be a little bit more than what is needed for a migration. So one of the customers that I've worked with is Smooch Labs, who created the dating app JSwipe. And a little history on this customer, they used to be using the Parse platform, which is a development platform that was put together by Facebook. And they came to us and they were looking for help with migrating their application from Parse to using MongoDB directly. So the way that Parse works is that it's an API that's built on top of MongoDB. So they were very used to using an abstracted version of MongoDB for their application. With that, they needed to understand how to use MongoDB and how they could take data from a platform where the only way for them to get a dump of it was raw JSON files from a backup. So they really needed some help figuring out how they could take that raw JSON and put it into Mongo, and then how they could access Mongo to make their application work. So we sat down and we worked with them quite a bit and got them a process where we would basically help them set up an ETL style process where we could extract the data from the JSON and transform it to work better in Mongo, and then we would load it into the database. And then we started helping them form their application access patterns to work with MongoDB directly versus through an API. And after that process, once we got everything moved over and switched over, then it was a process of going through and making sure that we were optimizing their application to work with Mongo, and to make sure that Mongo had the correct indexes and optimizations that it needed so it could run efficiently. So some of the key things that I want everyone to take away from this is make sure that you gather all the information that you need about your environment, your application, and also your future data needs. And this is going to help you choose the path that you need in order to have a successful migration. And with that path, that's going to allow you to put together the plan that is going to give you all of the steps and all the potential gotchas. You'll be able to clearly identify the areas where you have the most risk, so you can have a little bit of focus, more focus on those areas during the migration. And leveraging expertise, I can't stress this enough, because if there's anyone in your organization, that has worked on a technology that you're migrating to, or if there's a provider that you're moving to, lean on those people, lean on the support for those providers, and make sure that you're utilizing those resources, because it's going to be crucial to making sure that your migration goes successfully. So with that, it ran a little quick, but I'm going to turn it over to Kyle for some questions.
All right, thanks, Andy. Before we get started with the Q&A portion, I wanted to share that our migration assistance is included in our service, and that we have a free 30-day trial to help you get started. Okay, moving into the questions here. What database platforms do you support to and from, and will homogeneous and heterogeneous migrations be supported?
Okay, so database platforms, we currently support MySQL, Mongo, Redis, Elasticsearch, Hadoop, and Cassandra. And so far, the main areas where we've been asked for migration expertise in has been with Mongo, with Redis, and Hadoop is starting to come up a little bit, as well as Elasticsearch. For all of those platforms, we provide any migration assistance that is needed. I mean, we go through the process, like I said, where we gather the requirements, we talk about what is needed, and we set a platform, and we get everything going. We handle a lot of the nuts and bolts of it and the actual operations of the migration, so that way it's just an easy transition.
Perfect. Thanks, Andy. What's your recommended testing strategy to verify that a migration is successful?
This is a good question. This depends highly on the database technology that is being migrated, but some of the examples that I can give is when we're working with technologies like MongoDB, during the migration process, once we have data that's in both places, we can do things like we test queries. We will do things like test counts on both sides to make sure that the document counts match in spot checks, but really it's going to rely on the application. And once we get everything switched over, verifying that the application is accessing the data correctly and that it's seeing the data as it needs to. With other technologies like MySQL or Elasticsearch or Redis, I mean, these are all going to be very similar, but it's going to depend on the internals of those databases and the commands that are available, and it should definitely be part of the plan. But there isn't any external tools or anything that we use, because these databases really have everything that you need built in, and it depends application to application.
Got it. Okay, thanks, Andy. Moving on to the next one. After the cutover is complete, how long do you recommend keeping the old database?
So after the cutover, we usually hold on to ask that the old database is kept running for at least 48 hours. This way, more often than not, there are applications that may be legacy that someone didn't have documented or kind of forgot about. Maybe it's a server that runs in the corner of the office somewhere, and we kind of forget that it's there. And during that 48-hour time period, sometimes we'll see something, it kind of brings it to light that, hey, this server for some reason these reports aren't producing the information that we expect them to. So then we can trace it down and say, hey, this is, we're not seeing traffic from this IP that they're asking about. And the other side too is that sometimes there's data or there's usage for that server that that a customer has that they don't realize that they have until after we've migrated. So 48 hours is a good time frame. Some customers for their migration plans have wanted to keep servers up for a month or more just because of their internal requirements. So
perfect. Thanks, Andy. Okay, on the next one, do the reasons to migrate limit which paths discussed can be taken? So I think both of them relate to the reasons and paths you covered. Is there any sort of limitation depending on how those map to each other?
So this really depends. There are limitations whenever you're moving provider to provider. A lot of times you won't have the ability to do something like a cluster extension in that regard, because what we've seen in the past is if somebody comes to us and says, hey, we want to move to Object Rocket from another provider, then we reach out to that provider support team and we kind of talk to them a little bit about what we can do to help the client get set up. And there are some proprietary things that some of these platforms use that we can't have access to, which means that cluster extension could be off the table. So we have to look into doing something like custom code or doing a dump and restore. But outside of that, it really, the moving regions could be if you're talking about going from, say, like a US West region to London, because the latency there is so much greater than having something that's going from, say, Virginia to Dallas. So using cluster extension in that replication could cause some issues just because of network latency. But outside of those, usually you can get those done. The dump and restore is probably the one that has very few limitations aside from overall data size. Once you get into terabytes, the amount of time it takes to do that could be limiting. So,
got it. Makes sense. Okay, moving on to the next one. Are there some workloads that require additional planning or more steps to be successful?
That's a good segue from that. Yeah, when you have large amounts of data, there are some considerations that need to be taken. If you're trying to move 20 terabytes of data from one database platform to another in a different region, then you could be talking about the need to have to extract, transform, and load that data into a new structure for the new database technology, and then moving it across continents sometimes is going to be a lot more difficult because you can't rely on some of those internal mechanisms of the database. So you have to take that into consideration, and that's going to be a custom application thing where you're going to have to figure out a way to stream the data, and we do our best to help out with this, but this is going to be it's a big limiting factor when you get into large amounts of data and some of these platforms. As well, moving database technologies does just in itself will do that because that ETL process is usually something custom that needs to be developed. And really the biggest thing is the downtime consideration. Downtime, next to no downtime is something that requires a lot of planning and a lot of coordination in order to make sure that everything is successful.
Yeah, I think that kind of plays into the next question here. So my Mongo database is critical to my app and can't afford any downtime. Any tips Can you provide any tips?
Yeah, absolutely. So Mongo, I think, is the technology that I have helped migrate the most, and it's also probably the most black box to a lot of people because of how new it is. With the database being so crucial to the application, this is where I would definitely lean on using the replication that's built into Mongo to migrate the data. Now, with this, a lot of people will run Mongo in a single server architecture, which makes it harder because there's no replication by default when you're doing standalone. So some of the things that we've done in order to get around this is actually convert that standalone, take a maintenance to convert that standalone into a replica set. And then once it's been converted into a replica set, we've actually used the nodes in the new side to build out the replica set so we can get Mongo to do that migration for us. But if it's already set up in a replica set, then you're already ready to go. So you can just kind of extend it into your new environment, and that will help with reducing the downtime.
Okay, thanks. What was the most difficult migration you've helped with? I like this one.
So I think the most difficult was probably the example that we gave earlier with the customer from Smooch Labs, mainly because it was going from we couldn't take any of the methods that we talked about in here. This is more of a custom migration because we had to get a dump of data that wasn't in a form that we were used to or that we could use tools that we had at our disposal. And it was more about going through and helping analyze the data and figuring out the best way that we can put it into the platform. And also on the other side of that is a lot of the migrations that we work with are people that are already using the database directly, and they have application logic to use the database. But in this case, the application logic was written to access an API instead of using a database driver to use the database directly. So there was, during the migration process, there was also some training that we helped do to understand how to access the database directly with the application and what that would look like in the code. So that was one of the more difficult migrations because it was just a little bit more obscure than some of the methods that are here. But it was a really good experience because it shows that all these database migrations are snowflakes. So each one that you run into, the scenario is going to be different. Or even if you do 3 in a row that are exactly the same type and exactly the same technology, that there's something that's going to be different about it that you need to plan for and account for. But that one was definitely more difficult.
Yeah, it sounds like it. So that one kind of plays into the next one as well, right? So, how do you work with, where a customer's application code, it's their responsibility versus our responsibility? And to kind of further that one, right? How much are you willing to kind of get into the code with customers that use our migration services?
So we don't really do a lot of application services specifically, but in the case of working with the migration and working with these technologies, we help a lot with driver configuration. Using an as a service usually means that default drivers are set up to utilize connection configuration for servers that are right next door, or sometimes even on the same server as the application. So with that in mind, some of the settings aren't set up to handle multiple hops across the network or over the internet or something like that, or even to use SSL to keep that traffic secure. So we help with configuring the driver, testing that driver, and making sure those connections are working. And in the case of Smooch Labs, it was really just kind of a unique situation because they were asking us questions about MongoDB specifically that we were able to help answer. And to be honest, there was a lot of guidance towards the MongoDB documentation and driver documentation, because really that's the key. But it's a lot about MongoDB access patterns and common access patterns, and what we've seen is what we helped with more so than actually coding the application. So
got it. Okay, moving on. How much lead time should I plan for my migration? I have a large multi-node config.
Lead time for a migration will definitely vary based on the configuration, but one of the things that we work with here is that we need at least 72 hours before we start the actual process of the migration. That gives us the amount of time to start getting everything set up. Now, we've been doing migrations for quite a while, so 72 hours is an amount of time that we can work on, but we have quite a few people. We've got DBAs, we've got operations folks, we've got data engineers that work on this. Without those resources, I would say that it would probably need to be a week to 2 weeks of lead time before anything is even started, just to make sure that the info gathering and the planning is done correctly. And then from that point, the actual process from when you get started to when you are ready to do the cutover could vary based on the amount of data. It could be anywhere from an hour to a couple of weeks. So it really just depends.
Got it. Okay. And that makes sense, right? It's going to vary depending on your mileage, right?
Yep.
Okay, and the next one, my instance is not sharded. Do you still offer migration for replica sets?
So yes, we do offer for replica sets. The thing with the way that replica sets are set up at Object Rocket is a lot of the replica sets that we have are set to have a single database versus a multi-database. But with migrations, we've seen mostly through our jumbo replica set plans, which are 5 gig and above. And those, we absolutely have the ability to do migrations the same as we do sharded. And that's really sharded and replica sets in terms of Object Rocket. They're the same, but they're different, because sharding allows us to horizontally scale a lot easier if we start off sharded. But the underlying shards in that instance are replica sets anyway, and that's what affords us the luxury of using the replication during migration. And the replica sets are the same thing, it's just that they're not set up for that horizontal scaling. And not everybody needs it, and that's why they're there. So, okay.
All right, we had another one pop in. We're running out here. So, okay, does planning change if I move data from one data center to another versus providers?
So it absolutely does. Moving data from different regions, especially in the case that was brought up with moving from Dallas to Hong Kong, is definitely going to take some different considerations than if you're moving providers, because the amount of distance that's between those locations is going to impact the amount of time that you're going to have to spend having downtime or planning around different scenarios that you can do to move that data and limit the amount of downtime. Moving providers, a lot of times providers have regions that are pretty close to where our data centers are, so it makes it a lot easier to do some of this. The limitations with providers, though, like I mentioned earlier, was they may have some proprietary stuff on the back end that abstracts out Mongo that makes it harder to do that. Or some places, for example, that also do hosted Redis, they have a fork of Redis that they're actually utilizing instead of just the open source Redis like we do, which makes it a little bit harder to do some of those, use some of the internal mechanisms to do low downtime migration. So definitely is a consideration that like I said, every migration, it's a snowflake. We have to sit down and to get the whole picture and make a plan based on that. So.
Okay, we'll give it just one more minute and see if any last questions pop in. That was our last question submitted that I'm seeing right now. Okay, we'll call that done. So that's our last question for today. All the questions will be recorded. So if for some reason we missed one, didn't get it answered, we'll plan to follow up afterwards.
Ladies and gentlemen, that does conclude the webinar for today. We thank you for your participation and ask that you please disconnect your line.